So I'd like to invite Sander Grapendaal from Wageningen University and Research to the stage to talk about, maybe you can also switch slide.
Should I?
All right, the floor is yours.
Thank you. My name is Sander. I'm from Wageningen University and Research, part of a small group called Prime Diagnostics. And today I'm going to talk about upscaling xMAP kit production to support high throughput customers. So a little bit what we're going to talk about. We're going to talk about small introduction. What is Prime Diagnostics? A question we get a lot of the time. How to produce it, automatization, and Prime Calc, a new software package. So Prime Diagnostics is somewhere there, behind the big building. And we're actually part of Wageningen University and Research. And this way, we can really collaborate with experts in the fields, so doctors in virology, bacteriology, fungi, and so on. And our history. So it started in the 1900s with just collecting things that could infect plants. In the 1960s, we started developing the first antibodies, and they was collaborated with the entire Dutch agriculture sector. In the 1980s, we started upgrading, and we had the first, outside of the Netherlands, customers. And actually, in 2004, Prime Diagnostics, the brand was brought into life. And since then, we started upgrading to Luminex and other techniques. So there are three hallmarks which are Prime Diagnostics represents. We do development, production, sales for diagnostics for plant pathogens. So we don't do the testing ourselves. We just supply the reagents. We only do this with 18 people in all different fields. And our main focus is vegetables, potatoes, open field, and horticulture. And of course, healthy plants to feed the world. So what are dangers for plants? You got nematodes, viruses, bacteria, viroids, insects, phytoplasma, and fungi, all trying to harm plants. And at Prime Diagnostics, we only focus on these four. So how do we supply test? We got immunofluorescence, ELISAs, lateral flow devices, and Luminex xMAP. And we got TACMAN and Luminex xTag. So you can see this nice line. So basically, we got immunogenicity assays and molecular assays to support the customers. So that was Prime Diagnostics. Now the question we always get is, what is a lot of tests? It's a funny question to answer because there is no true answer, but I set up a case. So the standard test we do is DAS ELISA. So in the entire agriculture sector, DAS ELISA is the default test to do. And they always tell me, yeah, we do 2,000 plates. So 2,000 plates, is, give or take 100 wells a plate, is 200,000 wells. Then we ask, how many pathogens do you screen for? And they say, well, on average, we do 10 pathogens per plant. It's okay. Now we know it's 20,000 samples. And with ELISA, you always do duplos. So actually, they do only 10,000 samples. And now we have cases. So 10 pathogens for 10,000 plant samples. Okay, if we compare that to Luminex, 10,000, you no longer have to do duplos because you have your, every bead is its own assay. So 10,000 samples remain 10,000 samples. In case of multiplexing, everything can be done in one well. So we no longer need multiple plates. So 10,000 samples remain 10,000 wells. And then if you divide it by 100, it's 100 plates. Now, I'm not saying one is better than the other. I'm just saying one is maybe easier to handle than the other. And some of our customers take a full year to do this. Others only take 2 months to do 100 plates. So it's quite a struggle to keep up with production. So in the beginning, we did manual production. We just followed the Luminex cookmac book. We had these small tubes, and we did around 400 microliters of uncoupled beads. It took them 6 to 8 hours of work, and in the end, every batch had a different MFV value. So eventually, we started doing games, and that was who could get the highest MFV value in the end. These days, we do it a little bit differently. We automated it. So we also have some quality control on the production. And we do that with a goat anti-rabbit test. And that's because we just want to make sure that the coupling to the bead was good and not the efficiency of the antibody reacting to the pathogen. So we have different antibodies in the next slide. But however, they all have the same concentration. And they all went through the same procedure in the machine. Now, as you can see here, it's a quite big data point. So here we have actually 2013 was our highest number for manual labeling. And after that, we started doing coupling with the robot. And we stay within the 2 times standard deviation. So we can say, overall, we have a good stability of our coupling process. Now, actually, somewhere around here, we actually switched labs. And since then, you can see it's becoming a little bit bigger spread. So we think temperature has some influence on that. And since this presentation, we're actually working on stabilizing the temperature. But yeah, OK. So that's automation from our side. However, one of our customers took the next step and started automating their laboratory to process that high throughput. So I'm going to sketch a schematic overview from the top. So what they did, they bought 2 IntelliFlexes. They bought a robotic arm. They have 2, an input and an output hotel, and of course, a plate shaker. Because if it's in the input for too long, all the beads will suspend. So right before the measuring, they're put on the plate shaker. And of course, the big red button for when everything goes wrong. I think this is one of the first fully automated IntelliFlexes, or 2 IntelliFlexes, which is nice. So together with Luminex for the machines, PA for the robotic arm, the customer, of course, for taking the initiative, and help of us, we set up this entire device. And now they can run 2 plates every 20 minutes. So one IntelliFlex takes 20 minutes, and the other can run in the same time, which is around 600 wells per hour. Now, if you would do a 2-plex, that is 1,200 tests, but a 10-plex, it's 6,000 tests that are being done every hour. And this can also run overnight. So even when you finish up the lab, you can set everything up in the hotel, go home, and the next day you have all the data ready and waiting for you to be processed. Now, since this year, we didn't want to leave our customers just hanging in the dark with the MFV results. So we invented Prime Calc. And it's mainly to support our customers and assist in the calculations. So, OK, what is positive and what's negative? And it's a step-by-step protocol. So we think everyone can do it as long as you have this little bit of computer skills. So actually, we're going through the process. So we have the start button if you have actual data. But if you want to just practice, we also have the demo data set. And the first step is really easy. It's just copy and pasting all your data into the Excel file. And then you press proceed with new negative controls. So this is the nice part. Here you can just color in all your negative controls. And as you can see, we have negative sample 1 through 5. So they're negative for all the values. But we also believe that once it's positive for one sample, because we know we put it in there, it's automatically negative for the other targets. So here you just color it in. You do have to take into account cross-reaction. So these 2 viruses are from the same genus. They're both, they're code proteins are similar. However, with the antibodies, you can still see a difference in MFV signal. And then you press calculate. It does the calculation of your negative, the average times 3 times the standard deviation, times a factor 1.1, so extra 10% to be safe. And then it actually tells you what's positive with the red color and what is target of interest or potential infected in orange. Now, because we work with plants, every plant has its own chemical compounds. Some are more sticky, others are look way greener than the other, so to say. So we have the actual gain option. So you can adjust the background set or the threshold settings a little bit higher when dealing with succulents instead of dealing with potatoes, for instance. And then in the end, you get this nice report showing only positive, the sample, the location, the MFV value, and for which pathogen it is positive. Because, of course, when you're running a templex, you don't want positive, you want to know which pathogen. And the potential samples that you have to investigate. Of course, I don't do this alone. We have an entire team that supports me. And that was all. So thank you for listening